Okay, so we are going to do a little mini lecture on the problem-solving process that we're going to use for kinematics. And we're going to use an example of one-dimensional kinematics. When we get to two-dimensional projectile motion, we'll do another example of that problem-solving process. But this is the process we really want to use to solve all of our problems. It's all-encompassing. It tells us how we think about the problem. It talks about what's important in the problem, and it helps us identify all those things. So this is the outline of the process. We're not going to solve the problem today. We're not going to utilize the equations that we'll learn in the next couple of units. We're just going to think about how do we go about problem solving, and then this will keep coming back. So this is for kinematics, problem solving. And I'm going to use one of the problems that we've talked about when we first learned about how do we identify the time of the motion that we're interested in. And that'll be part of that problem. So the problem will read, you're driving down the road when a light 35 meters ahead turns red. After a reaction time of a half a second, you apply the brakes, coming to a stop just as you reach the intersection. If you're going 30 meters per second when you apply the brakes, and it took you 4 seconds to stop, what was your acceleration? All right, so if we're going to examine this problem, the first thing we want to know is what motion do we care about? What is the object of interest? So step number one is to identify the object. And in this problem, it's you, it's the car. However you want to identify it is okay, as long as you're understanding that you and the car are sort of one item. So we're going to identify our object as the car. All right. Then we need to think about what is the motion that we care about. So step number two is to identify the motion. And what I mean by this is the motion time. What starts and what ends that motion, like we learned about earlier. So in this case, we will identify that initial and that final. When do we start carrying? When do we stop carrying? And so we apply the brakes, we see the light. What is what we're actually interested in? Well, we're interested in the acceleration, that's slowing down, how much it takes, what that magnitude of that acceleration actually is. So it's when the acceleration starts to when we no longer care, when it stops. And so the initial is when we apply the brakes. So the reaction time is important in our life, but it's not the motion we care about. So when we apply the brakes, and it ends when we come to a stop. So that's what we mean by identifying the motion, identifying the time, the start and the end. All right, then we have to sort of identify the world. What is our world that we're interested in? So step three is identify the world. Now what we mean by that is we're going to define the space. In order for us to define the space, we have to know if we're working on one dimension or if we're in projectile motion in 2 dimensions, and if that space is in a coordinate system that we're used to, like that Cartesian, horizontal, earth horizontal, or if it's tilted. And we haven't gotten all those nuances yet, but this is where that will happen. So thinking about the type of motion, 1D or 2D, and we'll get to 2 dimensions and later, and the origin, and the coordinate system. All right, so in this case, we're driving along. We can identify the coordinate system as sort of that horizontal coordinate system. And here we have, the car. You don't have to be a great artist. And maybe we have the stoplight here. We have to identify an origin. So I might say that the origin is where the car is. Remember, you're in control of that. And all positions are relative to that location in space. So anything over here is going to be negative. Anything over here is going to be positive. So again, to the right of the origin are positive values. To the left of the origin are negative values. So keeping in mind what that origin really represents. So it told us in the problem that the stoplight was 35 meters ahead. And as I've drawn it, that means that the stoplight is sitting out here a positive 35 meters. So we can conceptualize the world that we're interested in. All right, the next step in our process is to identify our knowns and unknowns. And these are things that are going to be what's given in the problem, and as we learn more and more in our process solving, what is implied. And so it's a good idea to sort of think about all those players. We have initial and final position, the position at the beginning that I'm interested, the position at the end. Initial and final velocity, those instantaneous velocities, the velocity when I apply the brakes, the velocity when I come to a stop, the stopping actually being a part of the motion. The acceleration is another player, and time. So these are all the things we've identified previously as descriptors of motion and all the pieces involved in describing motion. Now some of them are given, some of them aren't. We need to determine that. So what's my initial position? Well, my initial position is 0 meters. Final position, well, I'm going to come to a stop. I have to remember, doesn't say where I come. Well, it says I stop just as I reach the intersection. So my final position is going to be 35 meters. My initial velocity is 30 meters per second. Sort of made these numbers up, so hopefully it all works out. My final velocity, if I'm coming to a stop, is 0. And it says it took me 4 seconds to do that. And I'm a little afraid these numbers aren't perfect, but we're going through the process, so we'll just get that idea. So this is what I'm identifying as being what's given to me in the problem. Now, I'm not given my acceleration, but we can make some ideas, think about some ideas about it. Do we expect there to be a non-zero acceleration? Well, yeah, it's changing its velocity. It's going from 30 down to 0, so we do expect this to be non-zero. It exists in a non-zero form and has a magnitude. And what direction do we expect it to be? Well, we can put that idea on there on our list as well. Well, if I'm heading to the right and I'm slowing down, we learn that motion in one direction and slowing down means the acceleration is opposite. So if I'm heading to the right, I'm moving in a positive direction. I'm slowing down, my acceleration has to be negative. So our prediction about the acceleration is that it's a negative non-zero. But we have to keep in mind that we don't know this. So we identify it with a question mark. It's not given, it's not implied. And as we do problem solving, we'll talk about what those values might look like if they're implied or whether they're given. But we can start making predictions about it so that we can evaluate it. All right, so this is conceptualizing sort of the whole problem. There will be a couple of more steps. So the next step that we can do at this point in our sort of understanding of the process is we can identify the player of interest. What player is going to answer our question? Well, our question is, what is the acceleration? So this is a pretty easy one to determine what player is going to answer our question. And we want to be explicit about identifying it, recognizing that we know what the question is going to ask and what will answer that question. The remaining steps are going to involve picking the equation, and we're going to learn about what those are, solving that, and then evaluating it. And this is going to help us evaluate. So I'm going to put those steps down so that you have them. We aren't going to solve this problem. This is the point at which we turn into solving. So we select the equation that will help us, our tool set. We then solve and evaluate. So these are the remainder steps that we'll learn as we look more into problem solving. But this is the conceptualization and defining how we start that problem. And that process is important. It's important for two reasons. One, it's what you're going to be doing in terms of solving problems. But it also lets you communicate your understanding. Identifying the object lets you tell me or your lab instructor that you understand what the problem is looking for, what object we care about, what the motion really is. Can I pull the important pieces out of here to understand what I'm analyzing? same as the process goes through. So these steps are things you have to do to problem solve. We're doing them explicitly so you're learning how to communicate your abilities to problem solve. So make sure you have these well written down somewhere handy so that you can keep using them over and over as we move into problem solving, because that's what we're going to be expecting, and it's going to make the process of problem solving go very smooth. All right, good job.